Okay, this will be part 2. Let me just make sure the camera is not moving. Okay, now so 18.2.2, right, is actually some of the property of integration. If k is a constant, we can actually bring out a k. This is similar to differentiation. If the two functions plus minus together, again, we can actually separate out. This is, again, similar to differentiation. And putting 1 and 2 together, okay, we can have this. This is the same as the factor rule and the sum and difference rule in differentiation. Okay, however, this is not true. Okay, even in differentiation, this is not true, and this also is not true. Now, in example number 3, okay, now to be able to actually integrate this, I can write this x minus x minus x, x minus 1 over x squared. Now, I can actually expand out. I will get x squared minus 2 plus x minus 2 dx. I prefer to write a bracket here. Okay, maybe I write better. Okay, this is like a plus b, the special product. A squared minus 2ab plus b squared. Okay, so I can do separately. X squared dx minus 2 dx plus x minus 2 dx. Okay, remember this is 2 plus 1. I can just simply write 3 here. This is 2x power 0, so 0 plus 1 over 1, and here will be minus 2 plus 1, minus 2 plus 1. So I'm going to have x cubed over 3 minus 2x. This is minus 1, so minus here. This is going to be x power negative 1. So I may choose to write in this manner. And then don't forget to write plus c. Okay. Now in similar fashion, okay, for part 2, well, I can actually use my binomial theorem. Okay, I can see that 2x minus 1, okay, power 3 will give me 2x cubed. Am I right? 2x squared minus 1 plus 3 2x power 1 minus 1 square, and the last one should be plus minus 1 cube. Remember this? Okay, 3c1 is 3, 3c2 is also 3. Okay, so when I expand, I will get 8x cubed here. This will be minus 12x squared. This is 4x squared. This is going to be plus 6x squared minus 1. So the integration will be integration of this. Can I just write nicely? 8x cubed minus 12x squared plus 6x squared minus 1. Sorry, again I have to write nicely. Dx, and remember this. So 8, I can just write 8. It's going to be x power 4 over 4. I prefer to write something like this. X power 3 over 3. Remember, 2 plus 1. This is 6. X power 2 plus 1. Oh, sorry, this is power 1, right? Okay, so this one must be 1 plus 1 is 2, and the last one is minus x. Do you agree? This is x power 0, and then remember the plus c here. Maybe I write down here. So this is going to be 2x power 4 minus 4x power 3, okay, plus 3x squared minus x plus c. Okay. Now, to do this, right, okay, maybe I share with you, right? Maybe I write here, okay. This one, if you were to divide, right, okay, this is x power 1/3. So this is going to be 3x. 2 minus 1/3. Okay, 2 minus 1/3 will be 5/3. Okay, and then this is going to be 2x power negative 1/3. Correct? Now, again, 3 I take out. I prefer to use a square bracket here. Now, plus 1 will be 5 plus 3, 8/3. 8/3. This one will be plus 1, 2/3. 2/3. Okay. Now, you should be able to get this answer. Okay. This is going to be 9/8. Okay. 9/8. X power 8/3. This is going to be 2 and 2 cancel, so 3x 2 power 3 plus c. So in other words, you have to do very slowly. Okay, I make use of this square bracket. It's easier for me to see. Okay, whenever I want to integrate. Okay. Now, for this question, right? Okay. The equation, find the equation of the curve. In other words, you want to find what is y. Okay. Given that dy dx is equals to 2x plus 8, and it passes through the point 2, 3. Okay, so again, y will be the integration of 2x plus 8. So this is going to be x squared over 2. This is going to be 8x. So this is going to be x squared plus 8x. Remember, this is your y, and remember there's a c. Please take note, this 2, 3 is a clue for you to find the arbitrary constant. This is 2 squared, 8, 2 plus c. This is 4 plus 16 plus c. Therefore, your c will be minus 17. So your equation of the curve will be y is equals to x squared plus 8x minus 17. Okay? So in other words, this clue here is to find the arbitrary constant.